Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about a Leetcode question number 628. Maximum product of three numbers. Given an integer array nums, find three numbers whose product is maximum and return the maximum product. So they are asking us to find three numbers from the array which can yield the maximum products. Okay. So see here, this is the example. See this first example, 1, 2, 3. There are only three elements. So you want to compulsorily multiply these three elements. So multiplying these three elements will give what? Plus 6. Fine. Now, see the second example. It is 1, 2, 3, 4. Okay. From this, what are the elements should I pick such that it will be a maximum product? I should pick this 2, 3, 4, right? So this can yield me what? Maximum product. Okay. See this last example. Minus 1, minus 2, minus 3. So there is no more option for me. There is only three elements. So pick those three elements. So it will be what? Minus 6. Fine. Now, the basic brute force approach for this example is that take a combination of all possible three pairs. So iterate from 0 to n. Again, iterate from, let us take this as I, then I plus 1 to n. Then again, let us take this as j, then j plus 1 to n for this k. And if this I plus k plus j, it is maximum, then take this as a result. So this is my brute force approach, right? Basic brute force approach. Okay. What is the time constant and space constant for this approach? For generating all combinations, right? So it is O of n cube. It's a time constant. And what is space constant? It is O of 1. Okay. So this is my first approach. Okay. Can we still optimize it? Okay. Let us consider that optimization. See here. Second part is about the optimization. Right. How to optimize it? See this example. 1, 2, 3, 4. In this, what should be my result? It should be 2, 3, 4. Yes. Okay. See this 2, 4, minus 4, minus 3. In this, what is my result? I can take this minus 4 and this minus 3 to make it as plus. Minus 4 into minus 3 what? It is 12, right? Okay. Now, I will multiply this 4 also. So, it will be maximum yield of 48. Fine. Now, take this third example. Here, I will take this minus 1 and this minus 2 and this 3. So that I can yield what is the maximum product? I can yield it is 6. Or else, if I take this 1, this 3, and any of this will become what? Negative. Okay, that's why I'm taking what? This 6. Hope you understand. Okay. Now, how to approach this problem is that, can you observe a pattern? See here, what we have took here? We have took the maximum numbers. We want only three numbers. Okay. If those three numbers is maximum, then absolutely the three numbers product will be maximum. Okay. So what is our first observation? First observation is maximum numbers of the array. Three maximum numbers. Okay. Fine. The second observation is that if the array like this, take for example this array and this array, there are possibility of a smallest number. This minus 4 is the smallest number. This minus 3 is the smallest number among this, right? This minus 4 and minus 3 are the smallest among this all array. But when we multiply this 2, I will get a huge value. So the second observation is that one maximum and two minimum. Can I observe this? These two are minimum. This one is maximum. Okay. Then can I take 3 minimum? You may ask, if the array is like that. Take for example, this is my array. Then I have a possibility of taking these three values. This is the first possibility. And second possibility is that I can take these three values. These three values. Okay. And the third possibility is that I can take this two values and this one value. Okay. And the fourth probability is that I can take these two values and this one value. Okay. Okay. If I take this purple, I will take two smallest and one largest. Okay. It's still valid. Fine. If I take blue, see here, I will take one minimum and 2 maximum. So 2 largest, one smallest and 2 largest. Okay, if the smallest is negative, then this whole number will be negative. Absolutely. If this for this example, take for example -1, 2, 3, 4. See here, I will take this 2, and if I take this 1, I will change what? Plus 12 to -12, which is minimum. Yes. Okay. If I have like 1, 2, 3, 4. Here I will take these three elements. Why should I take this 1 and this 3 and 4? Okay. So this cannot be my answer. Okay. Fine, fine, fine. Now, coming to orange part. In orange part, we are taking all three minimum. Okay. Take all three minimum. Okay. If I take all three minimum, take for example, if I have like -1, -2, -3 and 1. If I take all three minimum, what is my answer? -6. Okay. Let us take another example. -1, -2, 3, 4. If I take all three minimum, what is my answer? It will be -1 into -2, it is +2. Now 6. You may like, okay, it is a maximum product, but check here, it is what? 4, and if I take these two values, my value will be what? 8. So I cannot take it. I cannot take the sorry, three minimum values. So this also striking out. Okay. And at last, what we have? We have yellow. Okay. What is this yellow? Yellow states three largest number. So three largest number. Can we take three largest number? Okay. In this example stuff, we have seen that we can take three largest number. So what are the two possibility? Whether we can take two smallest and one largest, or we can take three largest. Okay. Three maximum number in array are one maximum and two minimum. So these are the two possibility I can take. From this two possibility, which is maximum, should be my answer. Okay. So what is my second approach? First of all, sort the array. Sort the array and check whether which is maximum. What is maximum? Whether three maximum element product is maximum, or one maximum and two minimum product is maximum. So this is my second approach. Right? Okay. What's my time constant and space constant for this approach? I can say my time constant and space constant will be O of n log n, because we are sorting it. Okay. What is my space constant? It is O of n, because we are using out merge sort. If I use merge sort, it will be O of n, right? Okay. So this is my time and space constant. Fine. Now we are going into the third approach, because here we use what? N log n and n, right? Still we can optimize it. We can check it. Okay. The third approach, still we want to optimize it. Okay. Whether it is necessary to find two minimum and three large maximum in sorted way. Okay. We want only three maximum and two minimum to compute. Okay. So for this, we want to sort, if the array size is 1000, if we want all 1000 elements in the sorted array, no, right? Okay, we can pick it. So how to pick it? First of all, we want largest, second largest, third largest. Okay, second step, we want smallest and second smallest. So these are the values we need. Okay, so how to find a largest, second largest, third largest? Okay, let me take an array 1, 2, 1, 3. It is not sorted. It is not sorted. Okay, now let me take the largest, second largest and third largest. First of all, I will take this one. Initially, these all are will be int min, or you may write like float of -infinity. Okay, these all are at int min. Let me take plus n. Okay, short form. Now I will take this one. One is larger than L. Whether it is larger than largest? Yes, it is larger than the largest. So absolutely, my largest element will be my second largest, become second largest, and second largest will become third largest. Why? Because I found an element which is larger than largest, then absolutely that largest should be what? A second largest. So int min will be assigned here, and this int min is also assigned here. So these two will not change, but here I will change this to what? 1. Hope you understand. Right? Now again, I will take this element 2. Whether 2 is larger than the largest? Yes. Yes. Then what should we do? I should take this one. Okay. And make this as 1. And make this as again minimum. And make this as 2. Can I understand this? If 2 comes, This 1 will be second largest and the second largest will be third largest. Okay. Now it comes to 1 again. Whether 1 is greater than this largest, no, but it is greater than or equal to the second largest, which means what? It can be the second largest and second largest can be third largest. So take this 1 and update here. Take this 1 and update here and put this 1 here. Can you understand this? Yes. Now, at last, I will take this 3. 3 is largest than the largest. So, I will take this 2 and convert to 3 and make this 1 as 2 and replace this 1 as this one. Okay. Now, what are the 3 largest numbers? I found it, right? 1, 2, 3 are the 3 largest number. Fine. Okay. Now, the same procedure is applied for smallest and second smallest. Okay, let me explain that also. Let us take smallest as what? Int max. Okay, and second smallest is also int max. Let me take as m. Okay. Now let us take an array like size of 4, -1, 2, -3, and let me take 0 or let me take 1. It is perfect, right? Now, see here. First of all, I will take this one, -1. Okay, whether this -1 is smaller than the smallest? Yes, it is smaller than the smallest. So this will be replaced as int max. This ss will be replaced as smallest, and this will be replaced as what? -1. Okay, coming to this 2. 2 is smallest than smallest? No, but it is smallest than second smallest. So replace as 2. Okay, now -3. -3 is smallest than smallest? Yes, yes. So make this -1 to here and make this -3, sorry, -1 to -3. Okay. Now coming to the last number, it is 1, right? So 1 is whether it is smallest than -3, no. Whether it is smallest than -1, no. Don't do anything. Don't do anything. Okay. So this is how we will find the smallest and second smallest. Fine. Okay. So at last we will apply the same formula that we derived in the previous approach. What is my time constraint and space constraint for this approach? I can say my time constraint will be O of n and space constraint will be O of 1. See here how much way we are optimized. Can you understand this? Linear time. Fine. Now it's time to see the code. First of all, m is equal to minus into min. Now I'm just traversing I from 0 to n minus 2 and then j from I plus 1 to n minus 1 and then k to j plus 1 to n, which means I'm taking all the indices combinations, right? Now I will take this 3 indices product, and if those element product is greater than the maximum, I will store in the maximum and I will return this maximum. Let me submit it. Yes, it is randomly exited error. Why? Because it is what complex time complexity is what? N cube. So n cube is huge because see here, what is the input size? 10 power 4. 10 power 4 means we can go at most what? N square. We cannot go beyond n square, right? Okay. That's why this code is not optimal. Okay, how to optimize it? I given the sorting approach, right? Just sort it and take two possibilities. What is the first possibility? I can take 3 largest number. Second possibility is 2 smallest number and 1 largest number. And return the maximum among them. Let me submit it. Yes, it is submitted successfully. Now, at last, the last approach is we want to take largest, second largest, third largest, and the smallest, second smallest in O of n complexity. We want to find them. Okay. Now, just traverse to the entire array, and if the current element is greater than or equal to largest, then what should I do? Third largest should be second largest should be largest, and largest should be current element. That's what I have done here. Now, I is less than L, and I is greater than or equal to second largest, then second largest will be updated now. Before that, we have to make sure that third largest should be equal to second largest, and the second largest will be current. Now, if the current value is less than the second largest, but it is greater than the third largest, then what should we do? Third largest should be I. Fine. Now, the same thing applying in the smallest and second smallest. See here, if I is less than or equal to smallest, then second smallest will be smallest and smallest will be I. Okay. If I is greater than the smallest, but it is less than the second smallest, means second smallest will be what? That current value. Fine. Now I'm taking the two possible combinations. Now I will return the maximum among them. Let me submit it. It is a linear time code, right? So it is way optimized than before two codes. Yes, it is submitted successfully. Now you may feel this approach is quite complex, but still you have to do it. Okay. Thank you.